I wanted to talk briefly today about the term AI in the loop and what it means for governance of artificial intelligence systems and their use in more and more pressing, challenging, impactful use cases. The term human in the loop has been around for a long time, and AI in the loop is a relatively recent development. But what does it actually mean? AI is increasingly used in mission critical and high profile use cases. In areas like defense, we see increasing use and interest in AI for sonar signal processing, for counter unmanned air systems, effectively counter drone use cases. And then equally in areas like insurance, we see massive use of AI for improving pricing, for fraud detection. And then in other sectors like civil infrastructure, AI can be used for detecting and quantifying the extent of damage, for validating costs and invoices, and there are many others. The challenge, of course, is that as these use cases get more impactful, get more critical, it means that mistakes in those use cases, mistakes in those workflows carry even more serious consequences and become far less acceptable. It's quite different to experience a mistake in an insurance pricing workflow or in a defense sonar workflow, say, than it might be in some generative AI, say, focused use case like personalizing a marketing email. And so that means that in these critical use cases, oversight and checks and balances to ensure that AI is not going off the rails, so to speak, is critical. It's vital to ensure that we don't end up relying on or over trusting AI systems and then having to deal with the consequences of those kinds of mistakes. Human in the loop was probably one of the earliest versions of this. It was an early approach to try and provide some kind of oversight and assurance that AI was doing what it set out to do and make sure it didn't go off the rails. And the general premise is that you have an AI process, as we see here in the circle, where a number of different decisions are made by artificial intelligence and by automated systems. And then humans are brought in almost as an afterthought to these systems as a minder to look after the AI and check its decisions and make sure that it's making the right choices. Comes with a bunch of challenges though, because of course part of the goal of AI is to automate and increase capacity. And so bringing humans into the process really limits a lot of that. Equally, AI can make decisions at speed and with vast amounts of data, far more than a human user can interact with and understand. And so bringing a human into that AI-driven world can be really challenging and actually massively neutralize or undermine many of the benefits that we set out to make with AI. And so we see the emergence of AI in the loop as a term. And really, when we think of AI in the loop, what we see is a fundamentally human loop. We see that the processes that are being undertaken are driven by humans. The human is still very much the center of this loop. The human is making the decisions. For example, in sonar signal processing, you will have a sonar operator who is still making those decisions. We're not automating the process and then adding the human, as an afterthought. We are very much keeping the human the center of the process and then thinking, where and how can we bring in AI to augment or accelerate certain parts or work alongside a human in a human AI collaborative kind of setting in order that we can accelerate the human in undertaking their work rather than trying to replace them, which is what we see a lot of the time with human in the loops. Fundamentally, we're trying to replace the human, which is probably a misconceived notion or an ill-conceived notion to begin with. And therefore, what this means in an AI in the loop kind of setting, AI can still perform tasks on its own when needed, but mostly the focus is on enabling the human operator to do their work. And that means that the workflow feels more familiar. It's designed with the human in mind, and we adapt the AI's capability and function to match the human rather than the other way around. It's not easy though, of course, because when we have humans and AI working together, in a collaborative setting or in an AI in the loop setting like this, it can decrease the level of automation. It means that the human operator is much more involved in all of the decision-making processes. And that equally can bring a high cognitive load. It can be challenging, mentally taxing for the human user to be this involved in potentially a massively accelerated, a massively more capable workflow, which can take quite a lot of learning and onboarding for them to get used to and happy with. It's also challenging to calibrate trust because humans, naturally, we've evolved to work with and trust and understand other humans, but we don't really understand how AI works. We're not evolved to deal with that, and therefore we can naturally be over trusting if we're not careful, or indeed if the AI is unexpected or acts in an unexpected way, we can be under trusting and we can have problems with adoption. So there are challenges, I suppose, there. And equally, just because we have an AI in the loop workflow, just because the human is the center, doesn't necessarily guarantee transparency. It can still be the case that a workflow can be designed poorly, or that we use the wrong model type, one that doesn't explain itself, doesn't explain its decisions or recommendations. And that can lead to mistakes still. So it's not a completely watertight or a given that an AI in the loop and a collaborative workflow will deliver good results. We've seen a lot of use cases where AI is being used increasingly in directly customer-facing applications, particularly with generative AI and the large variety of models that are available now in an off-the-shelf type delivery method. We're seeing a lot of chatbots and support assistants, which are using AI, and this naturally opens us up to significant risk. The problem, of course, is that the LLM's greatest strength is also its greatest weakness and biggest risk. LLMs are massively flexible. They can ingest almost any input in language and come up with a response to it, which most of the time is convincing. But this, of course, means they're also open to abuse, and especially when interfacing directly with customers, especially some customers who may be less technical or less experienced with large language models, it's possible for them to go off the rails and ask questions that are not appropriate, or that the large language model has not been designed or authorized to answer. And this can create real issues like exposure of private data, where the LLM shares information it shouldn't with a user, or inaccuracies and mistakes where the LLM gives a user advice that it shouldn't or is incorrect, or even offense or biased outputs if the LLM starts behaving in a certain way that the user finds not acceptable. The problem, of course, in these kinds of scenarios is that a human directly working with or keeping those systems almost human-centric is really, really challenging, because the whole point of large language models in these kinds of use cases is to be able to automate and scale and actually replace fundamentally human support agents. So it becomes really challenging to take an AI in the loop approach. That said, there are some things we can do, and AI in the loop can still be helpful. So the classic way that we deal with these kinds of use cases, where we're exposing AI to customers, directly to customers, is through a process called guardrailing. And effectively what this is doing is it's taking the output of a large language model, and it then assesses whether the output and indeed the input, the question, are on topic. Is this acceptable for the large language model to send back to the user? Is this within the bounds of what we expected? If a chatbot is designed to answer questions about support, then we wouldn't expect it to give financial advice around investments, for example. Guardrail models can be benchmarked in a number of ways, but it's important that the metrics and that the evaluation environment in which these guardrail models are trained must match the evaluation or the real world setting. We need to make sure that guardrails are robust to any kind of input that the large language model might see, rather than only guarding against a select few. For example, if we trained a model to ensure that it never gave financial advice because it's supposed to be giving support on, say, booking a car in for an MOT, and it should never give financial advice, fantastic. It might always say no to any financial questions, but if asked political questions, maybe it would break that guardrail and start offering the user opinions, which would not be within our intended use case. So the challenge, of course, is that as I say, we can't use a human, or we can't integrate a human directly into that loop to ensure that they're always in control. And so we need some other way of scaling that human impact. This slide gives a slightly more detailed overview, I suppose, of what we mean by guardrails. And in this given use case, we have a user on the left-hand side who is asking questions about how they can contribute to bird conservation in the UK. And this is what the system is designed for. Maybe it's a bird conservation large language model, bird conservation support tool, maybe working for a bird conservation charity. And what we have then is we have this blue box on the right-hand side, the light blue box, which is the guardrail. And the way that would work is that model would assess the response by the large language model. Using the system message as we see here, you're an AI assistant tasked with evaluating whether a chatbot's response is relevant to British bird charities. And when the LLM responds discussing bird conservation, it would pass, versus when the large language model talks about something irrelevant, such as what programming languages could be relevant, it would respond with a fail. And then in that scenario, the large language model, the system as a whole even, would either respond with the raw information through a pass setting, or in fail, there could be some system message that says this response has been recorded and has been denied because it seems to be off topic. So the challenge when training a guardrail system is that the problem space is huge. It's very complicated. As I say, the large language model's greatest strength, which is its flexibility and complexity, is also its greatest weakness. And so we need a way of covering that highly complex problem space, which means that we need a huge amount of training data and a huge number of evaluations to ensure that the large language model is robustly guardrailed and isn't going to be easily routed around, or that guardrail isn't easily going to be circumvented. The problem, of course, is that we might not have a large number of training or a large amount of training data around, for example, bird conservation charities and all of the other kinds of prompts that could be sent to the large language model. And so this is where we can take approaches which are pretty much AI in the loop and leverage things like semi-supervised and active learning. Semi-supervised learning is a really interesting approach. So we take a very large data set that only has some of the instances labeled, and then we use artificial intelligence to help us create labels for the unlabeled data. Active learning is a specific version of this where we use the user model to label or predict labels for the rest of the data set, and then we feed it back to a human user who can see where the predictions are wrong, where the model is not learning so well, so where those predicted labels are incorrect. And effectively, the model and the data set actively learns from the human user what the right labels are. And so what we can do here is, where we have finite human oversight, we have very limited human time available, we can use that oversight as effectively as possible to train a model on a very large data set by labeling that data set effectively. To add a bit more meat to this bone and explain, I suppose, in a bit more detail, the process in general works as follows. We have a very large data set, many instances of unlabeled data. And we then bring in our human labeler, and they maybe randomly, or maybe they select slightly more intelligently, but they go through the data set and they label some of the data points with the required output class. For example, this piece of data is acceptable, or this prompt is acceptable, this topic is unacceptable. Maybe they go through and they label a percentage, a small percentage of of the data set. The classifier model takes that partially labeled data set, it trains a model and makes predictions on the rest of the data set, on all of the unlabeled pieces, and then the human user can look at those predicted labels and find the labels which are most incorrect. Maybe those which are so clearly off topic but are classed currently as on topic, or maybe those areas which are very, very confident yet incorrect, where the model is absolutely certain of its prediction, but the prediction is wrong. And so in this way, the human user maybe then takes another 2% of the data set, which is incorrectly labeled, or where the model is clearly very uncertain, and labels those pieces. We end up then with a data set with more of it labeled. Maybe at this point we've been round twice, and so we labeled 1% to start with and another 1%. We've labeled 2% of the data manually, at which point the classifier model then trains again and makes predictions again on the data set. The human user looks again and sees, well, hopefully the prediction accuracy has gone up, but again then prioritizes which parts of the data set to label, again based on where the model is most incorrect or where it's most uncertain. Effectively, what we're looking to do is identify which pieces of data should I label to give the most knowledge, the most value to the model. There's no point in me labeling or confirming parts of the data set where the model is already performing very well. Where it makes the right decision and is very confident about that, I don't need to go in and manually label that because the model is performing well in those areas. But it's the areas where the model is not performing or where there is a lack of certainty that the model is going to get most utility, most value from me spending more time labeling the data. And what this then means is that over time, we go around this cycle a number of times, and exactly how many will depend on the specifics of the problem. But you then end up with a model which is very effective, and the human user has only had to label a very small or a comparatively small percentage of the data set, rather than going through and labeling vast amounts by hand. And effectively, really, we can think of this as AI in the loop, because we have a human process of labeling data by hand, and what we're doing is we're introducing AI into that loop to accelerate and augment the human process of labeling data. And in turn, what that means is that from a governance perspective, the human is able to scale their impact and help to monitor AI systems in a much more scalable and much more effective way. And this approach very much aligns with the EU AI Act and similar regulations from a principles and ethics perspective, because it helps us to operationalize the requirement for meaningful human oversight. While a human isn't directly sat there and watching a large language model as it makes responses, we are scaling human best practice and helping human operators to scale that best practice across all of those operational domains. And of course, active learning doesn't have to stop at the point of deployment. We can continue on an ongoing basis and maybe have human operators review any prompts which come through which seem suspicious or where the model is uncertain. And we can, on an ongoing basis, continue to refine and improve those governance approaches. This indeed resonates and generalizes and scales to many of the approaches that we use at Mind Foundry more broadly, not just in generative AI, but in other domains and other model types. Active learning and ongoing learning from a system as it's deployed in the real world is massive in terms of driving increased performance. Also in terms of being able to deploy a system earlier without necessarily having a completely locked down performance guarantee, but being able to take appropriately selected risks because we know that we can continue to iterate and improve a model once it's been deployed. So to bring this to a close, what do we mean by AI in the loop? I think it comes down to 3 key points. Fundamentally, we have to start with the fact that AI should support and not replace or supplant human decision making, especially in these critical and high stakes use cases. There's no way in which we should ever aspire to completely remove human oversight, even if that human oversight can sometimes be scaled using artificial intelligence itself. Further, we should lean towards guided collaboration and lean into the power of critical thought and collaboration rather than blind trust. It's all too easy to blindly trust an AI system and lazily turn off that critical insight. Just press yes, click to confirm without reading the terms and conditions. But really, we should all try and maintain that level. Indeed, we must in these high stakes use cases. We must maintain and lean into critical human oversight and critical thinking as a check and a balance for AI systems. And finally, of course, humans, experts, we have lived and breathed these use cases, these domains, and these deployment settings for an awfully long time, longer than AI has been around. And so we have built up a knack, a gut instinct, if you will, which is critical in making decisions that we know align with our values, our ethics, our principles. And it's really hard to convey or encode those principles directly, algorithmically into models. And so very much we at Mind Foundry believe that humans should be at the core of oversight systems and indeed AI systems more broadly, wherever possible, especially in high stakes, domain critical, mission critical applications. Thank you for watching.